In this example, we want to find the angle between the line L1 and L2. This is my line L1, this is my line L2. We already studied that we have two lines L1 and L2. We want to find the angle. We find angle between their parallel vectors. The angle between two lines is same as angle between that parallel vector. So I can find the vectors parallel to line L1. Vector parallel to line L1 is my A is vector parallel to line L1. So coordinate of A are coefficient of t 3, -1 and 2. 3, -1 and 2. And B is a vector parallel to line L2. So I have here the coefficient of the vectors here B is equal to, I'm having the coefficient are -1, -2 and 1. -1, -2 and 1. Now we can write the angle between these two. Theta is equal to cosine inverse of A dot B over magnitude of A and magnitude of B. We find the values and substitute here in our equation. I have A dot B, the dot product of these two vectors is equal to 3 multiplied by -1, 3 multiplied by -1 plus I have -1 multiplied by -2, -1 multiplied by -2, and then I am having here 2 multiplied by 1 plus 2 multiplied by 1. So I am having here this is equal to -3 plus 2 is equal to -3 plus 4, and that's equal to 1. Now next I need magnitude of A and magnitude of B. Magnitude of A is equal to root of A1 square. A1 square is 9. A2 square is 1. A3 square is 4. And the value will become here equal to root of 14. And then magnitude of B is under root sign of B1 square. B1 square is 1. B2 square is 4. B3 square is 1. So it's 1 plus 4 plus 1. This is root of 6. Now I can write my theta. My theta is equal to cosine inverse of A dot B over magnitude of A and magnitude of B. So I have here theta equal to cosine inverse of A dot B. A dot B is 1 over magnitude of A. Magnitude of A is root of 14. Magnitude of B is root of 16, root of 6. And that's my solution, angle between these two. Before I give you the detailed solution of example 8, I would like to remind you that we are having more examples in the notes and also more problems that you need to do the practice. And these notes are given in the description. The link is given in the description. You can just have the Google Drive. You can just download this one. Number one. Number two, I would like that you subscribe this channel and also press the bell icon that you find other videos which we are going to develop for this course. Next is our equation of the plane and the problem related to that one. Here we are having this example. We have line L1 and we are having here line L2. These lines may be intersecting, may not be intersecting. If they are intersecting, this point is x0, y0 and z0. We say this point is on line L1 when t is equal to t0. And this point is on line L2 when v is equal to v0. So we have this point x0, y0, y0, z0 in both the lines. It's on line L1 and also it is on the line L2. So in this way we use this one when they are aligned. This is going to represent the same point and we get here three equations. So we give you the solution of this one. So say this is on line L1. So on line L1 t is equal to t0. So get the value of x0 is equal to 1 minus 6 t0. Y0 is equal to 3 plus 2 t0 and z0 is equal to 1 minus 2 t0. And we say this is in line L2, then v is equal to v0 and we can put the value of v0 here. So my x0, the point of intersection is 2 plus 2 v0 and we having here y0 is 6 plus v0 and my z0 is equal to 2 plus v0. So they are going to represent the same point. So it means that we can just say that I replace here x, y, 0, y, z, 0, z, 0 with 1 minus 6t, 0, 2 plus 3t, 0. And from these two, we can get here the equations 1 minus 6t, 0 is equal to 2 plus v, 0. I get here 3 plus 2t, 0 is equal to 6 plus v, 0. And we get here 1 minus 2t, 0 is equal to 2 plus v, 0. Now we simplify it further. We take the unknowns, our t0, v0 unknown, and the constant to one side. So we get here three equations, minus 6t0 minus v0 is equal to 2, and take 1 to the other side, 2 minus 1 is 1. And here we are having 2t0 is equal, and then we take v to the other side, we get here minus v0. And the value of the constant, take 3 to the other side, we get 6 minus 3 is equal to 3. The last equation, minus 2t0. And then we take v to the other side, minus v0. And then we get here the result of this one is equal to, here is some small mistake. This is here is 2. So when this is 2, then we having here this 2. And this is 2, then we having here this 2. So this is the small correction in the question. Yeah, is okay, the solution. And they take 1 to the other side, we get here 1. So I have three equations. I have equation 1, I have equation 2, I have equation 3. If these three equations have a unique solution, then we say lines are intersecting. And if they don't have the unique solution, then lines are not intersecting. We have discussed the solution for a system of linear equation in the chapter 1. You can apply any one of the method to solve it. For simplicity, I am going to take equation 2 and equation 3. Equation 2 and equation 3, and find the value of v0 and t0, and I substitute in equation 1. If equation 1 satisfies, then we say the solution of all the three equations, and we say the lines are intersecting. And if it's not satisfied, they say line do not intersect. Let us see. We add these two equations because we can see this this plus 2t0, this minus 2t0, they'll be cancelled. So our action is we add e2 plus e3. Adding these two, we get here minus 2v0 is equal to 4, and we'll get right here our v0 is equal to minus 2. Minus 2v0 is equal to, this is cancelled, we get here minus v0 is minus 2v0, 3 plus 1 is 4. We get the value v0. We substitute any one of them, we get the value of t0. From e2, from equation 2, I can write here 2t0 is equal to v0 plus 3. So I get here 2t0 is equal to minus 2 plus 3. I get 2t0 is equal to 1, and t0 is equal to 1 by 2. So I have my result here. This is number 1, and this is number 2, value of v0 and t0. I have used equation 2 and equation 3, and if these values are going to satisfy equation 1, then this is the solution of all the three equations. Then we say the line intersects. This is the first part of our problem. And if these are not going to satisfy equation 1, then we say the line do not intersect. Now we substitute here. We take equation 1. Our equation 1 is minus 6t0 minus 2v0 is equal to 1. So t0 is 1 by 3. We get minus 6 into 1 by 2. Then we having here minus 2, and v0 is minus 2. So we having here minus 2 into minus 2. So we get here this equal to minus 3. This is equal to minus 3, and we get here plus 4 is equal to 1. This implies that t0 is equal to 1 by 2, and v0 is equal to minus 2, a solution of E1, E2, and E3. When the solution of E1, E2, 3, this implies lines intersect. So this was part 1. The one line intersects. Then if they intersect, if so, then we want to find the point of intersection. To find the point of intersection, we substitute the value of t0 here or v0 here, we get the result. I take the value of v0, I substitute here. Then taking v0 equal to minus 2, I get here x0 is equal to 2 minus 4, y0 is equal to 6 minus 2, and z0 is equal to 2 minus 2. I get here this equal to minus 2. I get here equal to 4. I get here 0. So the point of intersection is point of intersection is point minus 2, 4, and this is the case. We have seen they are intersecting. If they were not intersecting, then there was no point of intersection. I put the value of t0 equal to 1 by 2. Take t is equal to 1 by 2. It's 1 minus 3 is equal to minus 2. 1 by 2, 3 plus 1 is equal to 4. 1 by 2, 1 minus 1 equal to 0. We take the value of v0 equal to minus 2 or t0 equal to 1 by 2, we get the same point. So this is the idea that we can find two lines are intersecting. If they are intersecting is, as I mentioned, that we having the point, common point, and the line of intersection is x0, y0, z0. And this point of intersection means this is we're having two values. We can get the value t equal to t0 on line L1 and v equal to v0 in line L2. So we get here two equations. We replace the value of x0, y0, z0 by these values, and we get here the three set of equation. We take the unknowns to the left hand side, known on the constant on the right hand side. We get three equation. We need to solve these three equations, and if they have the unique solution, then line intersect. I consider here for my easiness, well, it's clear I can have the result from E2 and E3, add them, I get the value of V, and then put the value of V in equation 2, I get the value of T. I get the value of V and T, I substitute here in equation 1. When you substitute in equation 1, then equation 1 is going to satisfy. So we say if it is going to satisfy, it means that our T0 and V0 are all solution. To find the point of intersection, we just substitute the value of T0 equal to 1 by 2 or V0 equal to minus 2. We get the point, we take here V0 equal to minus 2. 2 minus 4 is minus 2, 6 minus 2 is 4, 2 minus 2 is 0. We get the point minus 2, 4 and 0.